Hello guys, and then welcome to another video. Okay, so in this video we trying to understand the concept of what phases and what sinusoidal quantities. Okay, kindly ignore the background noise because I'm really close to a very busy road at the moment. Okay, so without further much ado, let's dive right into this video. So the first thing first, in case you are new to this channel, kindly subscribe, hit on the bell icon so that you don't miss out on any uploaded video, and then like the video, okay, so that it gets pushed to other students who might also need this video with their academics, okay, to help their academics. Okay, so and then in case you have any questions, just leave them in the comment section and I will reply to them as soon as possible. Okay, so now let's look at how to add and subtract sinusoidal quantities. Okay, so there are three basic things you need to know when it comes to adding and subtracting sinusoidal quantities. Okay, so most of the time you might not know this, but you might be grooved into solving the questions. Okay, once you get the question and then you try going by any traditional approach, but once you know these tips, it helps narrow down your understanding and then calculation. Okay, so let's take a look at the three things you need to know. First, okay, always take the vector sum of sinusoidal quantities. Okay, so when adding and subtracting sinusoidal quantities, you normally take the vector sum. Okay, I hope you understand what vector sums are. Okay, you've already studied vectors in algebra, so you know what vector sums are, right? And then the second point is only sinusoidal quantities of the same frequency can be added or subtracted. Okay, so we will be solving some questions and you will get to understand what we mean by sinusoidal quantities of the same frequency. Okay, right? And then the third and the most important point is that when taking the difference of sinusoidal quantities, okay, we normally take the difference, maybe subtracting one sinusoidal quantity from the other. Okay, so the difference of sinusoidal quantities is obtained by first reversing the subtracted quantity and then adding it as a vector to the phases. Okay, so you already know from point one how to do what the vector sum calculation. Okay, so now once taking the difference of sinusoidal quantities, you first take the reverse, and then taking the reverse, this is how you take the reverse of a sinusoidal quantity. You add 180 to the sinusoidal quantities. Okay, whatever sinusoidal quantity that expression could be. Once you want to reverse it, okay, and then that's when you take the reverse. You take the you add 180 to the angle of the sinusoidal quantity. Okay, so let's take a look at some examples so that you get to understand. Right, so we've been given a certain vector, a certain sinusoidal quantity v1 at time t, okay, 60 sine omega t, and then we have v2 at time t, 80 sine omega t minus 90. Okay, right, so let's take a look at how we find out v1 and v2. So first we are looking at the solution. Okay, let's look at the solution for a. Right, so for a we could just draw this. Okay, so from here you know that these are x and y. Okay, so we know that this was 60 sine omega t. Okay, so we have the 60. Okay, the 60, that's our v1, and then we have v2 to be 80. Okay, right, so we have 60, 80, because the 60 is positive, and you could notice that the 80 is negative 90. Okay, right, and then we could have an angle from here. Okay, right, from the x. Right, now let's look at how you find out v1 plus v2. Okay, so first we take the absolute in complex numbers you might say is the modulus, absolute modulus. Okay, so let's take that. Okay, so we have that, and then that will be equal to 60 squared, okay, plus 80 squared, and this will give us 100. Okay, and then let's look at the angle. Okay, so taking the angle, the same thing applies. Okay, so from complex numbers you might say is that you have the modulus and argument, so you are taking the argument, right? So we have 80, okay, on 60. Okay, tan inverse of 80 on 60, and that will give us what? This will give us 53 degrees. Okay, this is 53 degrees, right? So now this is how you represent your sinusoidal quantity. So we have what? V1 plus V2, okay, to be equal to 100 sine of what? We have omega t, okay, minus 53, okay, minus 53 degrees. I'll show you why this is okay, minus 53 degrees. Okay, so let's move on. Let's take the second example. Okay, so we have second question right now. Okay, so we have v1 minus v2. Okay, so this is how, so we've implemented our what? Vector sum calculation. Okay, so vector sum addition, or vector sum is the same as addition. So we've implemented a vector sum method of sinusoidal quantities over here. Okay, right, and then we go to find a new what? V1 v2. Okay, so now let's implement what? And then we also use what? The second point, only sinusoidal quantities of the same frequency. So from here you can notice that these are frequency. Okay, omega t is a frequency. Okay, so they are of the same frequency, that's why they could be added. Okay, now and then let's look at what? The third point. That's when we taking the difference and taking the reverse by adding what? 180. Now, so you can notice that v2 is what? Negative. Okay, so we have to take the reverse. Okay, so this is how you take the reverse. So you have v1 minus v2, that's the main question. Okay, so this is how you take the reverse. We have what? v1 plus, okay, minus v2. Okay, so this is the same as the thing over here. Okay, v1 minus v2 is the same as v1 plus, open bracket, minus v2. Okay, so this is how sinusoidal quantity will look like. We have 60, okay, 60 sine the t, okay, and then we have plus 80, okay, 80 sine omega t, okay, and then we have what? Minus 90, okay, we have the minus 90 over here, and then taking the reverse we add what? 180, okay, 180 degrees to the angle. So we now have what? 60 sine of that, okay, and then plus 80, okay, sine of that. So we have minus 90 plus 180, that's what? Positive 90, okay, 90 degrees. So now this is our entire sinusoidal quantity for the reverse. Okay, so now let's take our what? Let's proceed with the calculation. Okay, so from here you can notice that you can also represent this on the what? Number line. Okay, so we have v1 and then v2. Okay, so you know that v1 is what? 60, right? And then most definitely v2 will be now positive. Okay, so from here we've taken the reverse. Okay, will be at this point, but it's still minus 80. Okay, keep that in mind. It's been reversed from, so it was supposed to be here. Okay, it was supposed to be down here, but we've taken the reverse, so it's now in the positive what? Portion of the number line. Okay, we know that these are positive y, these are positive x, these are negative y, and these are negative x, right? So let's proceed. So we have what? v1, okay, minus v2. Okay, so that will give us the same thing over here. Okay, so we are taking 60 squared plus 80 squared. Okay, that will give us 100, and then we take the what? Argument, or whatever you want to call it. Okay, we are trying to find the angle. So we have what? 80 on 60, that will give us what? 53 degrees. So now this is where the trick is. So now we have what? v1 minus v2 is equal to what? 100 sine of what? Omega t plus 53, okay, degrees. Okay, this is because we've taken the reverse. Okay, so in the next video I'll teach you how to solve this within I would say it's not even up to 60 seconds, okay, but you have to check with the various tips. So trying to check with the various tips might maybe add up so that you get to the time might elapse to maybe 60 seconds, but it's less than 60 seconds. You just have to know the 3 tips, and then you use your simple approach to find your final answer. Okay, you will arrive at this exact answer. Okay, so this, in case you cannot see this, this minus 53. Okay, minus 53 degrees. Okay, so let's proceed. Let's take the second example, or the second question. Okay, now, right, so we have what we've been given I4 to be equal to I1 plus I2 plus I3. Okay, and then we are told to find what I4. Okay, and then we've been given what I1 to be this, I2 to be this expression, this sinusoidal quantity, I3 to be also equal to this sinusoidal quantity. I hope you could see, right, because this well written. Okay, so let's see how we arrive at our answer. Kindly pay attention to this portion of the video. It's very important. Okay, so from here we can notice that we have 2 different frequencies. Okay, we have omega t, and then we have 3 omega t. Okay, omega t 3 over 3. Let me say w so that you get to understand what I'm trying to say. We have wt. Okay, it's not w, but let me just put it in that way. Okay, so that you get to understand. I don't want to be using terms. Okay, so we have 5 sine wt. Okay, and then we have 3 wt. Okay, so you can notice that we have 2 different frequencies. Okay, so we have to solve for both frequencies. Okay, so now let's start from the first frequency. Okay, so taking the difference from the first frequency, so you have to take the sinusoidal quantity in terms of the y direction and the x direction. Okay, just like this example. Okay, we took it from the x and y direction. Okay, from the x, remember that's why we introduced our number line, from the x and y direction. Okay, so that's the same method we'll be employing over here. So okay, so we are adding of this quantity. So let's say we are adding the first quantity. Okay, adding of this portion of the of the sinusoidal quantity. Okay, this portion. Okay, so where we don't have 3 wt. Okay, we are just concentrated on that portion. Okay, so let's see. Right, so taking the x component. Okay, so let's take the x component. Okay, so taking the x component, we have, for x components we normally use what cos. Okay, so pay attention. Okay, so we have, this will be 5 cos. Okay, 5 cos, so we don't have any angle over here, so we have 5 cos 0. Okay, so we have 5 cos 0. Okay, so we don't have any angle. Okay, plus, okay, kindly pay attention. Okay, so we have 5 cos 0. So note that we are taking only for this portion. Okay, let's say it's w. Okay, let's say it's w. I don't want to use a scientific term, so let's say it's w. So we are taking for only this portion. Okay, that's why we don't have something like 3 wt. We are taking only for wt. Okay, wt. That's where we are first concentrating on. Okay, so we have what, for the x component we have 5 cos 0, because there's no angle over here, but these ones have angles attached to them. Okay, so we have 5 cos 0, and then for x components we use cos. Okay, so let's proceed. We have 5 cos 0, and then we have what, 8 cos pi on 3. Now pi on 3 is what, 60 degrees. Okay, so we have 8 cos 60 degrees. Okay, and then let's proceed. We have what, 15 cos what, pi on what, 4. Now pi on 4 is also equal to what, 45 degrees. Okay, for cos we normally use a positive. Okay, so we have 15 what, cos 45 degrees. Now when you compute all of this, you end up with what, 19 point something like 61 or 607. Okay, 90.6. Sorry, this is not an angle. Okay, right, so we have 19.607. now let's proceed to the what, the y component. Okay, for y component, that's where you use sine. Okay, for y component we use sine. Okay, so try to get that and then you are good to go. And then don't worry, I'll introduce how you find your exact, you end up with exact answer by just doing the simple calculation within 60 seconds. Okay, so now let's see, we have 5 sine there's no angle over here. Okay, so we have 5 sine of 0, and then note that sine of 0 multiplying 5 will be will be 0. It doesn't exist. Okay, so and then let's proceed. We have plus, we have 8 sine right, you are correct. So we have 8 sine of 60. Okay, and then plus 15 sine of 45. now from here we have since we are using sine, this will be negative. Okay, but for cos it was positive. Okay, so we have minus 15. Okay, sine of 45 degrees. Now when you compute all of this, you end up with minus 3.678. okay, minus 3.678. so when you point this on your calculator, that's what you end up with. Now let's see, now if we are now come to find the modulus and an argument. So we have taking the modulus of the two quantities. We have we have the entire root of 19.607 squared. Okay, plus, let me extend that, minus 3.678. okay, squared. So this will give us so when you point this on your calculator, you end up with 19.949. okay, and then let's take the is it the argument, right? Let's take let's find the angle. So we have tan inverse of negative 3.678 and then divided by 19.607. okay, so this will end up with we will end up with an angle of, let's take a look at the angle. When you point this, you end up with minus 10 point something like 10.6 or maybe 62 degrees. Okay, so this is how you write out your sinusoidal quantity. Okay, so we have a final sinusoidal quantity for the first part, that's the omega or w. We'll have 19.949 sine again. Okay, minus, so we have minus 10.62, so 10.62 degrees. Okay, right, so this is the first portion of the calculation. Now let's take a look at the second portion of the calculation. So we are taking the we are taking the 3WT. so we have, let me use a different color. Okay, let me use a different color. Right, so adding this portion, so we have adding 3WT. okay, so from here you could just say that is you could add your t. Okay, so let's proceed. Right, so from here we are taking the s and y component for this portion of the question. Okay, so we have for s component, for s component. Okay, so let's look at that portion. Okay, so now for I1 we don't have any value for the s component. Okay, so that will be what? 0. Okay, plus we have 5 for s component. We use cos, so we have 5 cos what? There's no angle over here. Okay, so cos 0, so we have 5 cos 0, okay, as an angle. And then we have 8 cos pi on 3. You know that pi on 3 is what? 60 degrees. Okay, so we have plus 8 cos 60 degrees. Okay, so when you compute this, sorry, let me clean this up. So when you compute this, when you compute the entire of this, you end up with let's say this 0 plus 5 cos 0 plus 8 cos 60. Okay, so you end up with 9. Okay, this will be your value for this expression. That's for the s component. Now let's look at the y component. Okay, for the y component, we have there's no quantity over here, so that's also what? 0. Okay, so we have 0 plus, okay, let's proceed. So we have what? 5 sine what? 0. There's no angle over here, so we have 5 sine 0. Okay, so we have 5 sine 0. Okay, and then you know that sine 0 is insignificant. Okay, and then you have what? 8 sine pi on 3, that's what? 60 degrees. Okay, so we have plus 8 sine 60 degrees. Okay, so when you compute the entire of this, you end up with what? 6.93 or 928. Okay, so now let's find out the modulus. Okay, so we have modulus and argument. So we have the entire root of 9 squared, okay, plus 6.928 squared, and then this will give us what? 11.36. okay, 11.3, maybe 358. okay, and let's find out what angle. Okay, we have tan inverse of 6.928, okay, divided by what? 9, right? This 9, and then our final answer will be that's 37.59. okay, so right, so let's see how we rewrite this. Okay, so let's see. So now our sinusoidal quantity for the second portion of the what calculation will be 11.358. okay, and then we have sine of 3, let's say WT. okay, and then plus 37.59. okay, so now this is how you find your I4. So since we know that I4 is equal to the entire of I1 plus I2 plus I3, so we know that now I4 will be the total answer we had for both. So we have this answer, okay, and this answer. Okay, so our total I4 will now be what? Let's start from here. Okay, so we have 19.949, okay, sine of WT, okay, minus 10.62 degrees plus 11.358, okay, sine 3WT, okay, and then plus 37.59 degrees. Okay, right, so this brings us to the end of this tutorial video. Okay, so kindly subscribe, hit on the bell icon so that you don't miss out on any uploaded video. Like the video so that it gets pushed to other students who might need these study techniques to improve their grade. Okay, and then in case you have any other questions, just leave them in the comment section and then I will reply to them as soon as possible. Bye bye.